Let's do question 7b. Need to go back a bit and redo what we did in 7a. Question 7b will depend on what we got on 7a. So 7a, this is what we did. We say that the market value of John's house has increased at a constant annual exponential rate of 4.5%. So it means I there is 4.5%. And then our A was 3,500,000. And then N was the number of years between 1 January 2008 and 1 January 2021, which was 13 years, and we're looking for P. Okay, that's what we did in question 7a. So this is how we got our answer for 7a. We substituted our A, which was 3,500,000 is equal to P, and then 1 plus I to the power N. Oh, I'm substituting here. Okay, let me just rewrite it. So it's 3,500,000 is equal to P, and then 1 plus 4.5 over 100 to the power 13. Okay, then we divided both sides by this whole bracket. So we say 3,500,000 divided by the whole bracket here, 1 plus 4.5 divided by 100 to the power 13. This is 13 is equal to P. And then we got that P is equal to 1,974,950,74. No, 74, not 47, 74 here. Okay, so this is what we got in question or part A of the question. So now the question continues. It says now, Helen also bought a house on 1 January 2008, means same time with John. Her house cost 1,800,000. Its market value has also been steadily increasing, but at a higher constant annual exponential rate of 5%. If the houses continue to keep increasing in value at the respective rates, in which calendar year will two houses be worth the same amount? How does this assist you? Show all working. What can we do here? So we're saying in which calendar year? In which year? So what must we do here? We need to find N, when these two houses will be having the same amount, isn't it? So same amount. What clue does it give you? It means we must create two equations and solve them simultaneously. Okay, remember how we solve simultaneous equations? We can solve simultaneous equations by substituting. We can solve simultaneous equations by elimination. We can solve simultaneous equations by equating. So we're going to have the component for Helen and then the component for John, and then we equate those and then we solve for N. Actually, if you check here, we are saying we want to find the calendar year in which the two houses will be worth the same amount. Okay, so it means we're going to have the A value for Helen, isn't it? We're going to have the A value for Helen, 1 plus I to the power N, and then we're going to have the A value for John. You see that? So we're looking for N when these two are equal. When these two are equal. We also do this in algebra. Do you remember that? Right. If you say we're looking for the x values where f of x is equal to g of x, it's the same thing. So these are the functions here. We're equating these two functions. So we want to find N when the A for Helen is equal to the A for John. isn't it? Right, let's see. So we're still using the same formula, but now let's say for Helen. For Helen, okay, what is P? Because now P, that's the original price of the house. So P is equal to 1,800,000. Okay, and then I, the interest rate, is going to be 5%. Remember, I said here you can use your decimal 0.05 or even your percentage 5%. You just put the percent in the calculator there. And then N, that's what we're looking for when these two houses will be having the same value. And then for John, what we have for John here, John P, that's the amount we calculated in A. So John, right, P is equal to 1,974,950 rand 74 cents. Okay, and then I, the interest rate, is still 4.5%, because they say that their respective rates. You see that? And then N, we're going to find N when these two houses will be having the same value. Okay, so now let's substitute into our formula. So it means let's start with Helen's one. Is going to be 1,800,000, then 1 plus 5% to the power n. It should be equal to John's house price. So it's going to be 1,974,950 rand 74, and then 1 plus 4.5% to the power n. Right, you see that? So now we have to solve for n. We have created our equation here. We have equated the two components. Okay, we have equated them. So we're solving simultaneously by equating. You see that? Right, now let's go to the part where we're going to solve for n. So now what do we do here? What can we do? We want to isolate n. We want to isolate n. So we can divide, let's divide by this bracket on both sides of the equation. So let's say, let me just divide here. I'm going to divide here by this. So I'm going to divide 1 plus 4.5%, okay, to the power n. And then again, we divide by the same thing, 1 plus 4.5% to the power n. And then this bracket divided by this bracket, we get 1. What do we remain with? We remain with 1,800,000. I'm taking a longer step. So some of the steps you can skip them, isn't it? I'm taking the longer step because I'm explaining, right? So you can also what? Oh, I have this 1 plus 5 over 100 n divided by 1 plus 4.5%. 4.5% divided by n is equal to 1,974,950.74. See that? And then still we have this 1,800,000. You can divide both sides by it. Let me just do that here. So we're going to divide here by the 1,800,000. And then also here divide by the 1,800,000. Like I said, you can skip some of the steps here. Okay, do that. And then what we have, we're left with, or let me use the space here, we're left with 1 plus 5% per n is equal to divided by 1 plus 4.5%, okay, is equal to what? Let me just remove this. Okay, is equal to 1,974,950,74 divided by 1,800,000. You see that? So that's what we have here. Okay, that's what we have here. But remember, talked about the laws of exponents. Remember this. Let me just write it here. If we say y over x to the power n is just equal to y to the power n over x to the power n. Do you remember that? So we can move from this to this, or even from this to this. Okay, so now let's move from this to this. You see that? Using that, so we can say, let's simplify this. This is like 1,05. If you put this in the calculator, you can put this in the calculator. Or this is 0,05 plus 1. So it's 1,05. And then we simplify this. It's going to be 0,045 plus 1. So it's 1,045. And then to the power n. Okay, using what we discussed here. Using this. Okay, this is equal to, we can also divide these two, and then you get 1,0971948. You see that? Okay, now we have to solve for n. What are we going to do here to solve for n? We have to change this equation from exponential form to log form, isn't it? It's very easy to change from exponential equation to log form. Do you know that? Okay, we said, let me just write here what we have here. We have 1,05 over 1,045 to the power n is equal to 1,0971948. Right, now I said we're changing from exponential form to log form. If you're changing from exponential form to log form, just know that this is your subject. The exponent is the subject of the formula. Then this is the base. This is the base. Subject, base. So it becomes n is equal to log. Remember where the base goes? Here. So it's 1,05 over 1,045. Then if you just know these two, this is the subject, this is the base. Done. And then your number, or some say the number, or some books they will say the argument. Okay, and then we have 1,0971948. You see that? You put this in the calculator, you'll get your answer. Okay, right. What is the answer? Let me see if I have space here. Okay, I have this. So we put this in the calculator. What we have, n is equal to what? 19,4. Right. So now, if we answer the question, if the houses continue to increase, to keep increasing in value at the respective rates, in which calendar year? So we want the calendar year here. We know it's going to take what? 19,4 years for them to have the same value. But now, which calendar year here? From 2008. Okay, from 2008, 1 January 2008. So if we add 19 years to 2008, it's going to be 1 January 2027. So it means within 2027 there, because this is 19,4. So it means the year, therefore the year is 2027. Done. Okay, that's what we're supposed to do. Thank you very much. Welcome.